Teacher video work again with Mrs. McElveen. Let's take a look at our problem for this week. Charles is making muffins. The recipe calls for 1/2 cup white flour and 3/4 cup whole wheat flour. He is making 2 batches, so he needs to double the amounts given in the recipe. What is the total amount of flour Charles will use? Let's read it again. And this time I'm going to underline information that jumps out at me. Charles is making muffins. The recipe calls for 1/2 cup white flour and 3/4 cup whole wheat flour. He is making 2 batches, so he needs to double the amounts given in the recipe. What is the total amount of flour Charles will use? Okay, I'm going to think about the action. I did this over the weekend, except I was making pancakes, and I doubled the recipe. So Charles, instead of pancakes, he's making muffins. He needs 1/2 cup of white flour and 3/4 cup of whole wheat flour to make 1 batch of the recipe. He's going to make 2 batches though. He's doubling the recipe. So, and then we want to find out the total amount of flour that he needs to use. So, let's think through things over here. 1/2 cup white, 3/4 cup whole wheat, and then double. I'm going to write double down here. Double. I know if I double something, I do it 2 times. Times 2. I'm not going to freak out about multiplication though. We thought through this already, and I think we'll be able to solve it. So he has, if I'm drawing a picture, 1/2 cup white, that's 1/2, and then 3/4 cup whole wheat, and then he needs it again because he's doing it twice. White, 1/2, whole wheat, 3/4. And I forgot to write up here, we want the total. Finally, he needs to know how much flour he's going to use in his recipe. So I know for 1 batch, that's going to be 1/2 of the white flour plus 3/4 of the whole wheat flour. To make another batch, his second batch, or to double it, to put it all together, he needs 1/2 plus 3/4. So there are lots of ways I could work this out together. I think I'm going to start by combining the things that are the same. Oops, and I just noticed that says 1/3 and this should say 3/4 instead. That's why I have to look back at my work carefully. I noticed that these 2 are the same and these 2 are the same. So let's put things together that are the same. 1/2 plus 1/2. I noticed right away, same denominators. I don't have to do anything. Plus, I know a lot about halves. 1/2 plus 1/2 is 1 whole. Now let's do my 3/4 plus 3/4. Okay, again, my denominators are the same, so I can just add 3 plus 3 is 6/4. Oh, but this is an improper fraction, or a fraction greater than 1. So I need to change it into a mixed number. And then I need to combine it back with this 1. Okay, so 6/4. I'm going to draw a picture of this. Here's 1 bar of fourths. 1, 2, 3 lines to make fourths. 1, 2, 3, 4. Here's another bar of fourths because I'm not done. 1, 2, 3, 4, 5, 6. I could even number these if I needed to help myself keep track. So 6/4 is the same thing as 1 whole and 2/4. Oh, some of you right away are probably saying, Mrs. McElveen, 2/4 is the same thing as something else. Let's think about the problem. 1/2 plus 1/2, that was doubling the white flour. That's white flour. 3/4 plus 3/4 is doubling the whole wheat flour. So that's whole wheat. If Charles is making muffins, he has to put both of them together again. So I have 1, the doubled white flour, plus 1 2/4, the doubled whole wheat flour, which is 2 2/4. Now 2/4 I know is an equivalent fraction for 1/2. If I color this in even darker, 2/4 is the same thing as 1/2. So he needs 2 1/2 cups of flour to make his recipe, his total recipe. This is what you should use for your example today, or this week, excuse me. It's a separate page for your partner work and your independent work. You can use my example. If you have another way of showing your thinking in similar situations, you can do that too.